top one. So let's talk about this one. Remember with order of operations, what did I tell you about numerators and denominators? What do we know about them even if we don't see symbols? They are what? They're actually grouped, all right? So you can think of this as a group. So before you can do anything to the group, you have to get rid of something that's not in the group. So in this case, you would actually do that division first, the inverse of that division, because that numerator is grouped, okay? And because it's grouped, you can't touch it until you get rid of the 2. So what is the 2 doing? Adding, subtracting, multiplying, or dividing? What is the 2 doing to that group? It's dividing. So how do I get rid of the 2? I multiply. So I actually need to multiply both sides by 2 first. Okay? Because that numerator is grouped. Once I get rid of the 2, I can just look at it because I've gotten rid of something that's not in the group. So if I multiply by 2, it's going to change that to a 1. And I just have the 5 minus y now. If I multiply this by 2, I have an 18. Now how do I move the 5 over? I need to zero it out. Yeah, so I subtract, okay? So I'm going to subtract a 5 over. It will zero it out here. What's left on the left-hand side? A negative y. On the right, I have 13. I am not done yet because my y is technically not by itself. What's in front of my y? A negative 1, right? Negative. So how do I get rid of that negative 1? What's that negative 1 doing? Addition, subtraction, multiplication, division. It is multiplying, so how do I get rid of it? So I divide by a negative 1. Now I have my y by itself, and 13 divided by negative 1 is negative 13. And that's how I came up with this particular answer here. Of the $395 that Carlos collected for the fundraiser, $310 was in 10s and 20s, and the rest were in 5s. How many 5s did he collect? What's my variable going to be here? What do I not know? The number of 5s. So my x is going to equal the number of 5s. All right? I know his total amount was $310. His total is going to equal how much he had. Oh, $395. Sorry, I wrote the wrong one. His total's $395. That's going to equal how much he had in 10s and 20s, right? Which was 310 plus how much money he had in 5s. This represents the number of 5s. How do I figure out how much money he had in 5s? So if you have 4 5s, how much money do you have? 20. What did you do? You multiplied by the value of the $5 bill, right? So if I have a number of $5 bills, I need to multiply that number by the value of a $5 bill, which is, what's the value? 5, right? So plus 5x. So 5x represents how much money he has in $5 bills. Not the number of $5 bills, but the dollar amount, right? Those two should equal the 310, which was his 10s and 20s, plus however much money he has in 5s. All right. So then to solve it, I'm just going to subtract, right? This is just a positive minus a negative, so just subtract the way you normally would, right? And then I would divide. And 85 divided by 5 is 17. So I have 17 5s. And you can check it. 17 5s would mean $5 per each 5. So 5 times 17. And then add that to the 310 and see if you get 395 there. All right. So when you are simplifying equations, you want to make sure every side is as simple as it gets before you start actually solving. Do I have like terms? Yes. Make sure you combine all of your like terms. Once it is as simple as it gets, you're just going to solve the way we've been doing it. Add or subtract first, multiply or divide to solve. All right? Now, once again, this is not simplified yet, so I will not start solving until it is simplified. This one's a little more complicated. In order to simplify this, I first have to do what? I can't combine like terms yet. What do I need to do? Yeah, distribute. So I have a 3 here, and I have a negative 1 here. That is what I'm going to distribute, all right? So I'm going to take the 3 and I'm going to multiply through. 3 times x is 3x. Yep. 3 times positive 1, positive 3. Negative 1 times positive x is negative x. Negative 1 times negative 2, positive 2. So pay attention to your positives and negatives there as you multiply and distribute, all right? Is that as simple as I can get it before I start solving? Why not? I have like terms, right? So I have a 3x and a negative 1x. How many x's do I have? 2x. I have 2 x's. I have a positive 3 and a positive 2, so I have a 5. Now, this is as simple as it can get before I actually solve. Now I'm going to solve, just like I have been. Subtract my 5. I get a 2x, don't forget your equal sign, and an 8. My final step here is to divide. X equals 4. And you can always check these. Go back to your original and plug it in. And then do order of operations. So if you plug a 4 in, you're going to do parentheses, exponents, multiplication, division, addition, subtraction. All right? And then you're just going to see if you get a true statement. John's mother is 4 times as old as John, and John's brother is twice as old as John. If you find the sum of their ages and add 3, you get 80. What are the ages of the 3 people? All right? So they relate everybody's age back to one person's age. Which person's age do they relate it back to? John's age, right? So that's really the thing we don't know. We're going to say, well, X is going to equal John's age. All right? And then we are going to write each one of these as in a relationship to John's age. John's mother is 4 times as old as John. How do we write then John's mother? How would we write 4 times as old as John? 4x, right. John's brother is twice as old as John. So how are we going to write John's brother? 2x. And we already said that John's age is represented by an x. Then it says if you find the sum. What does sum mean? Adding. of all of their ages. So if we add John's mother's age, John's brother's age, John's age, and something else. What else do we need to add? 3. Then we will get what? 80. All right? What is it asking for? What's the final answer that they want? All of their ages, right? All 3 people. So when we are done, how many answers should we have? 3 answers, okay? This will be tempting to stop at just what John's age is, but we won't be done there, okay? So now we have an equation that we need to simplify. We have 4 x's, 2 x's, 1 x's. How many x's do we have? 7x plus the 3. I'm going to subtract my 3, right? 7x equals 77. Divide by the 7. X equals 11. What did we solve for? John's age. So John is 11 years old. How do we get his brother's age? Multiply by 2. How do we get his mother's age? Yep. Now we have answered the question. So you were not done with the question when you just solved for your variable, okay? So this is why you have to go back and say, did I answer my question? Yes, I did. Now you're done. The number of girls is 2 fewer than 3 times the boys. She has 26 students in her class. How many boys? So my variable that I don't know is the number of boys. All right. I technically don't know the number of girls either, but they did relate it for me. They said 2 fewer than 3 times the number of boys. Remember when they use fewer, you reverse the order. So 2 fewer than 3 times the boys is 3 times the boys minus 2. That's how many girls I have. So if I have 10 boys, I'm going to multiply by 3 and subtract 2. I'm going to have 28 girls, okay? So that's what this is telling me. Then it says she has 26 students in her class. That's the total number of students. If I take my boys and add my girls, those are my only options, boys plus girls, that should equal my total students. Those are my only options here. So if I add the total number of boys plus the total number of girls, I should get the total number of students. Well, the total number of students is 26. My boys, I said, was x. My girls, I said, was 3x minus 2. Now I'm just going to simplify this. This is a 1, so it really doesn't change this other than takes away the parentheses. So x plus 3x minus 2. I combined my like terms to get the 4x minus 2, and then I just solved. This is as simple as it gets. So I'm going to add 2 to both sides. gives me 28 equals 4x. I'm going to divide both sides by 4, which gives me the x equals 7. So then I want to make sure I answered the question. They really only asked for how many boys were in the class. They could have said how many of each, how many boys and how many girls. And then I would have had to go back and solve. I could take the 7 away from the 26, or I could plug the 7 back into the 3x minus 2. But they just asked for boys. So I have set up the equation, which is one thing they asked for, and I have solved for the number of boys, 7 boys. So this seems kind of out of the way, but this is an interesting little bit they add into this section. You can change repeating decimals into a fraction. All right, so remember when we talked about number sets. The definition of a rational number is that it can be written as a fraction, which means it is a repeating or a terminating decimal. We understand terminating decimals. 1/4, that is 0.25, okay? We also understand how to get repeating decimals. 1/3, that's 0.33333. But now we're going to go the opposite direction. We're going to get a repeating decimal and we're going to change it to a fraction. All right, so look at this example 4 on page 76 in your books. All right, this wants us to express 0.36 as a quotient of integers, okay? So we don't know what the integer is. We don't know what the fraction is. So we're going to say we don't know what that is, but we know it equals 0.36 repeating. Okay? Now, since it's repeating, I can actually write it if I wanted to. This means the same thing. 0.3636, right? I mean, that's the same thing, right? Now, here's what I want to do. I want to take however many digits are repeating, and I want to multiply both sides by 10 to that power. So basically 1 with the same number of zeros. So I have how many digits are repeating here? How many digits are repeating? 2. So I am going to multiply both sides by 100. 2 zeros, okay? So on this side, I'm going to get 100x. Multiplying a decimal by 100 just moves the decimal over 2 places. So it just does this. It moves it and moves it, okay? That's what it does. So this ends up being 36.36 repeating. That's all 100 does. It just moves it over. Now I really want to get rid of that repeating, all right? What did I say the repeating equals? Way up here. What does that repeating equal? 1x, right? So I said that x equals this guy repeating. So what I'm going to do is I'm going to subtract an x. If I subtract an x, right, what can I subtract on this side? The repeating. So I'm going to subtract the 0.36. All right. What's 100 minus 1x? 99x. I subtracted my repeating. What am I left with over here? Just a 36. How do I solve? Divide. So I'm going to get x equals 36 over 99. By the way, when you have a just a repeating decimal, nothing in front of it, not a whole number in front of it, it's always going to work out to the repeating decimal over that number of nines. So I had 2 digits repeating. It's going to be the 2 digits over 2 nines, 99. 0.3 repeating. It's going to be the 3 over how many nines you think? Just 1 9, right? 1 3 is repeating. So I have 1 digit repeating. It's going to be that guy over that number of nines, all right? If I had 0.35 repeating, it's going to end up being that guy over 2 nines. It's always going to work out that way when it's a repeating decimal. Just the decimal. We're going to do one with a whole number in front of it. But if it's just the decimal, it's always going to be the number of nines. Now, I'm not actually done here because I have something in common. I can actually reduce this. What goes into both of those? Yeah, something bigger though. You can start with 3. If you start with 3, you may see it. What's 36 divided by 3? 12, right? What's 99 divided by 3? Yeah. What goes into 12 and 33? 3 again. So you could have, I heard someone say 9. You could have taken out a 9. But you can always start with something smaller. If you don't see the larger one, you end up with 4 over 11. That is how you would write this repeating decimal as a fraction. Every repeating decimal can be written as a fraction, which is why they are rational numbers, not irrational. Okay, they can be written as a fraction. Questions on that one? All right. All right, if you didn't do the long way, how many digits are repeating? 2. I don't have anything in front. This is only if there's a 0 point whatever. So I have 81 over how many 9s? 2 9s. Can I reduce that? I can reduce it. What goes into 81 and into 9? 9. So divide this by 9, divide that by 9, right? And I believe that's as small as you can get it, 9 over 11. All right? So for this one, only the 6 is repeating, okay? So you're going to actually do this really the same method here, but you're going to have to work it out really the long way because it doesn't really lend itself too nicely towards a shortcut. So we're still going to set it up as x equals this guy right here. All right. How many places are repeating? 1 place is repeating. So we are going to multiply by just a 10. Yes. And when I multiply this by a 10, I do move this over. Okay. And I do want to take it out. So I have 13 and I want to say 0.66 repeating. So I do want to put more than 1 there. Okay. So it might be easier here to, like, when you know you're going to move it over, to write it out however many places you're going to move it over, really. All right. I am still going to subtract 1x from both sides. So I'm going to subtract an x here. What did my x equal? Well, that was 1.36 repeating. So I'm still going to subtract 1x and subtract what the x represented. Okay. 10 minus 1 gives me a 9. Over here, my repeating 6's will cancel. Then I have 6 minus 3. Don't forget to line up your decimal and bring it down. 13 minus 1 is 12. I've actually gotten rid of my repeating decimal problem, okay? My final step to solve is to divide by 9, okay? But my goal here is to get a fraction. So I have x equals 12.3 over 9. We don't have a decimal and a fraction together, right? We're trying to get it all to a fraction. So here, I'm going to do this little process. How many decimal places do I have up here? That's 1. So scooch it over and scooch that over. So you end up with 123 over 90. Okay, so you want to get rid of those decimals by just moving it over. Whatever your numerator moves over, your denominator moves over, and fill in your blanks with your zeros there. You can do it with 9 as well. So this is divisible by 3. Divide that by 3, divide that by 3. 3 goes into 12 4 times, into 3 1 time. 3 into 90 is 30. That is your answer, by the way. All right.